So today we are going to be working on graphing rational functions that have nonlinear asymptotes. So far we have graphed rational functions with horizontal asymptotes and then oblique or slanted asymptotes, but now they could even be nonlinear. So typically we'll see a lot of quadratic asymptotes, so parabolic, but we could also see cubic asymptotes. We probably won't see any higher powers than that. So just as a little warm-up refresher, go ahead and in your notes that of course you are completing as you go, go ahead and find vertex form for those first three parabolas to practice. In addition to that, also just describe where the vertex is and whether or not the function is going to, or the parabola is going to open up or down. If you need additional time, go ahead and pause the video now because I'm going to uncover the answers. So pause for as long as you need. All right, welcome back. So go ahead and check your work and you can see our parabolas in vertex form as well as where the vertex is and whether or not the parabola is opening up or down. One thing to notice on number 3, we also have a stretch there. So that one is going to be narrower than a standard parabola by a factor of 2. It also opens down. All right, so now that we're warmed up and ready to go, now let's go ahead and take a look at our actual rational function that we're going to work on today. Okay, so the very first thing that we're going to do, as with any other, we're still going to factor first. Factoring helps us decide if there's going to be a hole, anything we can remove, and simplify. So go ahead and factor, and just like before, go ahead and pause the video if you need a little bit of extra time. All right, so you can double check your factoring work, and then from here we can see that we do in fact have a hole. We've got an x minus 2 and an x minus 2 that cancel, and so our hole is going to happen when our x value is positive 2. Now I like to, when I'm factoring, write out my perfect square trinomials like I did up here with x plus 2, x plus 2. Then later on when I write the function, I'll write that as an x plus 2 quantity squared. But that way when I go to cancel, if that one of those were to cancel, it makes it a little bit more streamlined. All right, so then just like before, right, most of this is going to be review. We're going to find the y value of our hole, so we're plugging in 2 into what's remaining from our function. So we might as well go ahead and write what's remaining in our function now. Okay, once you have checked your work on that, then go ahead and plug in 2 for x over here in what's left over after we canceled out, after we removed our removable discontinuity. And then from there, we can either write it as the top-heavy, of course fully reduced, fraction 64/5, or since we're going to be graphing this, I like to think of it in terms of a mixed fraction, so it's 12 4/5. Just go ahead and leave a fraction though, not a decimal. The only place for decimals would be if you have to use a quadratic formula for those intersection points with the NVA. All right, so now from that factored form, from our new in quotes function, we can go ahead and find our zeros, vertical asymptotes, y-intercept, and then begin our sign chart. So go ahead and find those first 3. Okay, remember the zeros are from your numerator, so we've got a 0 at the origin, and also add an x value of -2. So we've got -2, 0. We're of course writing those as ordered pairs. And remember the shortcut, if you have a 0 at the origin, you'll also have a y-intercept at the origin. Now vertical asymptotes come from the denominator, so we've got an asymptote at a +1 value and a -3. Those are vertical lines, so we do need to write them as equations of lines, so x equals and x equals. Okay, so then from here we're going to work on our sign chart. Now for the sign chart, remember we're using our zeros and our vertical asymptotes, oops, right here, only, nothing else. So we've got 4 boundaries. We also have 4 positions in our function. So we'll start with those boundaries. And of course they go in order. And then what we're going to do is we're going to be filling in little positives and negatives depending on where we are on the sign chart. And one thing to notice is up here in the numerator, we've got an x squared in our first position, and we've got an x plus 2 quantity squared in the second position. In the numerator, both of those spots, both of those factors are squared. If there's a squared factor, notice I said factor, not term. If there's a squared factor, that's going to be a double. What that means is on the sign chart, the sign won't change on either side of that position. Now it also means that that location, so the upper left as well as the upper right, will never be negative. So in my sign chart, I'm just going to fill in little plus signs right there all the way through. Now in the denominator, those factors are not squared. And so for very small values, anything less than our smallest value on the sign chart, -3, if we choose something like -5, and I don't even usually bother to put numbers in because I'm just looking at if I have something really small and it's not squared, it's going to be negative. So in both locations, it's negative. If you are feeling uncomfortable, then pick something smaller than -3. So for example, -10. -10 minus 1 is negative. -10 plus 3 is still negative. So in the bottom over here, I'm going to put negative and negative. Okay? So then overall, I have a positive times a positive divided by a negative times a negative. So really I've got a positive divided by a positive, or a general positive value. Okay, and remember you can count the number of negative signs. If it's even, like we have here, 2 negatives, then it's going to be an overall positive value. Now, when we're looking for when any signs will change, that is going to happen, come on, that's going to happen only as we cross over these values, and only if one of those values is not from this numerator up here. Oh, what a pain. From this numerator, that is where everything is squared. So let's see, when we cross over -3, so we're looking at values getting larger than -3, well, -3 came from this factor. Okay, and so as we cross over -3, that's not squared. Now that location will turn positive, but nothing else will change. So the lower left, the x minus 1, will remain unchanged. Now as we get bigger than -2, well, that came from this double up here. So at that -2, at that double zero, nothing in the sign chart is going to change on either side. So we've got this negative positive in the denominator. We're going to keep negative positive in the denominator. And for both of those, that's an overall negative because we've only got one negative sign here. Okay, next we're crossing over 0. We're getting values bigger than 0. Well, 0 is where this x squared, we got it from there. And so that position is also a double. We've got a double 0 at the origin and at -2, 0. So the sign will remain unchanged. And I'm going to keep that bottom of my sign chart the same as the last one. Okay, so nothing changes on your sign chart when you pass through a double, whether it's a double 0 or double asymptote. Now finally, in our last position, we're crossing over +1. Everything else is positive except for this location. This is where +1 came from. So that now finally will change. Nothing else changes though, because we've already updated everything else. So now we can see we have no negative signs. X minus 1, that factor in the denominator, was not a double. Neither of our vertical asymptotes are doubles, so the sign should change on either side of those. Okay? All right, so there's our sign chart. We have no change around our two doubles, but we do have changes everywhere else. So now for the rest of the problem, we are going to need our unfactored form. For whole zeros, vertical asymptotes, all the way through sign chart, we need our factored form. But now we need to expand this out. So go ahead and expand out your function where we have removed the whole and write that down. Okay, be honest with yourself. Pause the video if you need. Here's our new function. All right, so we've got that, and we're going to use that for our long division. Okay, so go ahead and divide this new function, f of x in quotes. So that tells us that our NBA is this quadratic function. And so we can write it in a couple of ways, right? We can write our quadratics in standard form, where it's just in descending order, y equals ax squared plus bx plus c, right? What we use when we plug into the quadratic formula. Or because we're going to have to graph this, we might as well put it in vertex form. In terms of your information over here, I'll take either one, but since you're going to have to graph it, you might as well put it in that form anyway. So go ahead and transform this equation, your quadratic asymptote, into vertex form. Okay, so what we can see from this is we've got a vertex at -1, 2, and it's opening up and it's a standard width. And so I wrote my NVA in vertex form here. Now, when you are writing down your, your above-below section, the function is approaching that non-vertical asymptote. Remember, we've written the y essentially here. It says f of x is going towards. That's what that arrow means. It's approaching. So we don't want to write -2 equals because we want everything on one side of the equal sign. So either write just the quadratic version or add 2 to both sides. Either one. So you can write it this way, or you could also write it this way. Either one means the same thing. So now let's also look for any intersections we might have with the non-vertical asymptote. Remember, that's when the remainder from your long division, in this case 9, when we set that equal to 0. Well, but 9 doesn't equal 0, and so we have no intersection points. Okay, so then the last thing we need to do is talk about the end behavior. What's happening on the far left-hand side of our graph and on the far right-hand side of our graph when the x values are at their extremes. Okay, so remember we're looking at f of x going towards the non-vertical asymptote, our answer from the long division. Non-vertical asymptote plus the remainder, 9, over the original denominator, and really just the first term there. So just the x squared. Remember, it's okay to be lazy here. Now, I didn't even bother writing the non-vertical asymptote because we're not plugging in there. We're not thinking about values there because we just know that we're approaching that parabola. Okay, so either far right or left side there. And so what we're thinking about is plugging in a negative value into this fraction. Well, 9 is going to be positive no matter what. So we have a positive divided by a negative squared. Well, that's also positive. And same thing if it's positive, right? A positive squared is also positive. So either way, we're approaching the NVA plus a little bit. So it's going to be from above that parabola. And so since this parabola is opening up, it's going to sort of be on the inside of the parabola. Okay? So now we're ready to graph. We've done all of our analysis. We know what's happening here. So let's go ahead and graph this rational function. All right, so we've got all of our information, and we're going to start the same way as before. We're going to start with any key points that we have found, plot those, plot your whole, include all of your asymptotes. Don't forget to write or draw your asymptotes as dashed lines. So this non-vertical asymptote, now that it's nonlinear, starts to a lot of times end up being a solid line, and then it gets really confusing with your graph. So still make sure to draw it as a dashed line or a dashed curve in this case. Even though the axes were drawn for you on this one, be aware that you have to be really careful of your axes from here on out. So because our parabola is opening up, we wanted to shift it down. We didn't want to shift it all the way down because we still need to see some of what's happening down here. So that's why it's shifted part of the way down, just not all the way. Okay, so go ahead and take a minute to draw in all of the key information, and I'll do the same. Okay, so now once you have your whole plotted, your zeros plotted, your y-intercept, which is one of the zeros, your two vertical asymptotes, and your non-vertical asymptote plotted, we have no intersections with the NVA. Once you have that carefully drawn in, then we're ready to start doing the rest of the graph. Now you can see why it's so important to be so super careful in particular with drawing your parabolas. Mine's a little bit lumpy just because I'm trying to draw with a cursor. But you can see why we have to fill the graph as well, because we really now need all of this space. Okay, so let's start down here with our above, and in this case, above. So if we're above that parabola, one way to test is if you go to your curve, if you can go up from there, that's going to be above. So in this case, on the inside is slightly more up than it would be if you were down. So both on the far left, and here's the far left side of our graph, and the far right, we're above that curve. So we're essentially on the inside of that curve. Let's get a little close. Okay, so we've done that part. And then we also need to use our sign chart. So I'm going to do my asymptotes first. So surrounding the left asymptote at -3, I'm positive on the left and negative on the right. So on the left-hand side, I'm going up because it's positive. On the left-hand side, it's negative, so I'm going downward. Then I'm going to my next asymptote at 1. I'm this time negative on the left and positive on the right, so here's the left side of that. I'm going down towards that asymptote and on the right side here. Okay, so now we'll look at the zeros. It's negative surrounding all of the zeros. So in between here, we're going to go from this portion of the graph, we're going to go up to the 0, but then we have to dip down. Now remember, you don't have to necessarily know how far you're dipping down as long as you're showing that it's negative. Don't show it going really subtly across, even if the value is really, really close to 0. Just make sure it looks like it's less than 0. And then we'll come back down and attach. So we can draw that part right now. Go up to your 0, but it needs to stay negative. So I'm just going to do a little dip to the next 0 and then connect to the next portion of the graph. So that's surrounding our zeros and our sign chart, our vertical asymptotes. We've done all of that. But then we still have to connect our arrows in here. And so you'll notice that this graph is very symmetric. And a lot of times you'll see some of that symmetry where our asymptotes surround the vertex in a symmetric way. And so everything about this graph should be pretty symmetric. So even though there's a hole here and there isn't a hole over here, the shape of the curve should probably match on the left and right hand side. So I'm going to start on the side with the hole because we have to connect these two arrows but dip all the way down enough so that we're going to at least touch that hole. So I'm going to connect here. And then we don't really know how far down it's going. I'm just going to do a little bit and then loop back up. It really shouldn't look like it's going back through the hole. It's a little bit tight for space in there. And of course, mine kind of looks like it's crossing the asymptote. It doesn't really cross the asymptote. So now I'm just going to reflect that over here. And I'm just going to go approximately as low on this side. So then it looks somewhat symmetric, even though there's no hole. And I'm just following the shape of that asymptote as I go, knowing that I have to connect the two arrows. Okay, so now we'll double check if we have everything. We've drawn in the hole, yep, zeros, vertical asymptotes, y-intercept, we did our sign chart, have our non-vertical asymptote, there are no intersections, and we did our above. So then the last piece is to label all of your points. So go ahead and label your hole and your two zeros. So now you officially can draw graphs of rational functions with non-linear asymptotes.